properties of impulse function. Let's take this question. Question number 3. Integral minus infinity to infinity t square e power minus t square by 2 delta 1 minus 2t dt. This is what we have to solve it. What is the answer for this? Think about it. What it can be. Let's say first, take this function as x of t. Take this function as x of t. Then what is this function? Delta 1 minus 2t. Can I rewrite this as delta? Just I am jumbling these two. Minus 2t plus 1. I can write. Just I am jumbling these two. So addition is a commutative property. If I take minus 2 common out, 1 by mod minus 2, which is 1 by 2, delta t minus 1 by 2. That's what it is. So if I replace it with this, integral will become integral minus infinity to infinity, let's say x of t, delta 1 minus 2t can be written as 1 by 2 delta t minus 1 by 2 dt. So if I take 1 by 2 common out, 1 by 2 x of 1 by 2. That's what the final answer is. So in this function, t has to be replaced with 1 by 2 finally. 1 by 2 into t square, that means 1 by 2 whole square into e power minus 1 by 2 square by 2. Finally this is 1 by 8 e power minus 1 by 8. This is what the final answer is. Okay, take it. Let's say the next question. Question number 4. Integral minus infinity or better if g of t is given like this, this is what g of t, and here a tends to 0. Then what is the value of this integral? Then integral minus infinity to infinity sine 2 minus t pi by 2 by t square plus 7 g of t dt. What is this value can be? Can you try this one and tell me what the answer is going to be? Think about it, what they are asking. So many people think that it is a different question which is not involving impulse function, but still it is an impulse function. How, sir? Okay. First, forget about this question. Try to understand about the g of t. So here, g of t, it looks like a rectangular. It looks like a rectangular pulse. It looks like a rectangular pulse. If I say what is the width minus 1 to minus 1 by a minus 1 minus a, which is nothing but a. So the width here is a, height is nothing but 1 by a, height is nothing but 1 by. What if somebody is asking area? That is a into 1 by a, which is nothing but 1. Now let's say, suppose if I take a value is equal to 1, then 1 by a is equal to 1. So finally 1, 1. We can get area is equal to 1. What if I take a is equal to half? Then 1 by a is nothing but 2. Here is the half, but height is nothing but 2. But still, what is the area you are going to get? If a value keep on decreasing, height keep on increasing, but still, what is the area of this rectangular pulse is 1. Again, if I decrease the a value, let's take a is equal to 0.1. A is equal to 0.1. Then 1 by a, which is nothing but 10. 0.1 width, height is nothing but 10. Still, the area is equal to 1 only. So this point is keep on coming here. So at a very one particular point where a value is tending to 0, a value is almost all 0. That means this point is coinciding, and 1 by a goes to infinity, but still area is equal to 1. That means finally if a tends to 0, we can get an impulse function at, this is g of t, 0. Here we are going to get an impulse function at minus 1, which is nothing but delta t plus 1. Delta t plus 1. Because if a tending to 0, minus 1 get coincide, and 1 by 8 goes to infinity, but still area is equal to 1. That means it is becoming an impulse function at 1. So I can rewrite this g of t as nothing but delta t plus 1. Then this integral, let's assume the part up to this point is x of t, then integral minus infinity to infinity x of t delta t plus 1 dt, So this is nothing but x of minus 1, simply x of minus 1. So in this function we have to place t with minus 1. Sin 3 pi by 2 by minus 1 whole square plus 7. Finally, minus 1 by 8 is the answer. Minus 1 by 8 is nothing but the answer. So this is very, very important. So many previous GATE questions are also based on this. So remember, when a value tending to 0, 1 by a goes to infinity, and this will become impulse. Okay, take it. If x of t is given like this, this is what the x of t is given. They want to find out then integral minus infinity to infinity x of t delta t minus 4 dt. This is the value what we require. It looks very easy, but very difficult question. Okay. So can you try this question? What the answer might be? So many people think that answer is 10. That's not correct. Not at all correct. So many people think that answer is 10. See, here forget about this waveform. If this is the integral we want to find out, I can simply say t has to be replaced with t naught. In this case, its value is equal to 4. Finally, its value has to be x of 4. If suppose I ask at t is equal to 4, what is the x of t value? That is nothing but x of 4 value. Everybody thinks that its value is equal to 10, but it is not correct. Why, sir? Here at 4 we are having a discontinuity or sudden jump. So it is suddenly going from 10 to 0. Its value is 10 to 0, dropping to 10 to 0. So whenever there is a discontinuity, the value can be undetermined. That's what the meaning of discontinuity. We cannot say the value. The value is any value between 0 to 10 actually. The value can be anything between 0 to 10. That's what the meaning of discontinuity. Understood? So I can simply say at 4, x of 4 value is undefined, undetermined. So it is undefined actually. This is undefined. What is that means? That is any value between 0 to 10. 0 to 10. So in the examination, one option is undefined. Directly we can go for undefined. What if the options are given like this? Option A, let's say 10, option B 0, option C 5, option D, let's say 2. Which option we have to choose? We have to choose 5. Why, sir? Actually, this 5 is given by Gibbs. This is Gibbs. What do you mean by Gibbs phenomena? So let's see, try to understand. Gibbs phenomena comes into picture when there is a discontinuity. If you try to find out the value of the function at the point of discontinuity, the correct answer is undefined. There is no bar on that. We can simply say undefined. But somebody is forcing you to say the value. Suppose somebody is forcing you to say the value. Then you have to say some value. Then where you can land on. Then there the Gibbs phenomena comes into picture to find the value of the function at the point of discontinuity. What the Gibbs says is, if you try to find out the value at 4, then do one thing. Take the value just before 4 and just after 4 and make the average of it. Then that's nothing but the discontinuity value. That means, let's say, just before 4, what is the value? 10. Just after 4, the value is 0. 10, 0. 10 plus 0 by 2. Average value is equal to 5. I hope you understood. That's what the Gibbs value. So this is nothing but 10 plus 0 by 5. Sorry, by 2. Which is nothing but 5. So this is what the answer. So undefined is the correct answer. Next, second priority goes to 5. Suppose in the options, undefined is also there. Undefined is also there. Then which one we will choose? Undefined we have to choose. Undefined is the first priority answer. 5 is the next priority answer. Remember this. 10 and these values are never. So it may be undefined, it may be 5. So if both are given, go with the undefined. Okay. So let's see, what do you mean by Gibbs phenomena? Gibbs phenomena. It is used to find the function value at the point of discontinuity. At the point of discontinuity. At the point of discontinuity. If T0 is point of discontinuity, then x of T0 is nothing but x of T0 minus, that means just before t0 plus x of t0 plus, that means just after t0 by 2. That's what the average value just before and after the discontinuity point. Okay, take it. So whenever there is a discontinuity, the best answer is undefined value. Its value can be anything between 0 to 10. So in this part, it can take any value between 0 to 10. That's what the meaning of it. But somebody is forcing you to say the value, then you have to go with the Gibbs phenomena. What it is saying that it's the average value just before and after 10. Unit step function. Unit step function. The notation is u of t. Mathematically, how we can define this? U of t is equal to, it's maybe 1, maybe 0. Its value is 1 when t strictly greater than 0, t strictly less than 0. So if I try to represent this graphically, u of t function, up to 0 its value is 0, after 0 it suddenly goes to a new value 1. This is what the u of t function. So before 0 its value is 0, after 0 its value is 1. Suppose somebody is asking what is u of minus 1? Before 0 its value is 0, so we can say 0. U of minus 3.5, this value is also 0. U of, let's say 1, 1. U of 2, 1. U of 2.5, 1. U of infinity, that is also 1. U of infinity value also 1. But what if I ask u of 0? What if I ask u of 0? If you observe carefully, at t is equal to 0, there is a discontinuity. Just now we have seen that if there is a discontinuity, if you try to find out the value at the discontinuity, the correct answer is undefined. Undefined. Correct value is undefined. That means it can take any value between 0 to 1. It can take any value between 0 to 1. That is any value between 0 to 1. Any value between 0 to 1. But if I am insisting you to say some value, then what we have to say? It is nothing but 1 by 2 by Gibbs. By Gibbs. Why, sir? See, average value just before and after. Just before to 0, its value is 0. Just after 0, its value is 1. Then for 0 and 1, the average value is nothing but 1 by 2. So that we can say by the Gibbs phenomena, the value is 1 by 2. But undefined is the first priority. 1 by 2 is the second priority. Okay, take a note. If I ask, draw u of t minus 2. U of t minus 2. That means, let's see, try to understand. U of t is 1 or u of t may be 0. Its value may be 1, its value may be 0. When t greater than 0, that means the argument value is positive. The argument value is positive. Then its value is equal to 1, obviously. When the argument value is negative, then its value is 0. That is as simple as that. So if I say the same thing, u of t minus 2, when the argument is positive, that means t minus 2 is greater than 0. That means t greater than 2, its value is 1. So how we can draw this? Up to 2, its value is 0. After 2, we are having jump. Its value is equal to 1. That's what the meaning of u of t minus 2. If I draw u of t plus 3, so then whenever this is positive argument, that is t greater than minus 3, it is starting from minus 3, 0. Its value is 1. So this is the function how we have to write. Okay, take it. So here also we are talking about argument. Argument is positive, argument is negative. Then it's going to be 1 or 0. In the similar manner, if suppose somebody is asked you, draw u of, let's say, sin t. Again the same thing. Whenever the argument is positive, I am not talking about t now. I am talking about entirely sin t. So sin t is positive, we can get 1. Sin t is negative, we can get 0. That is as simple as that. If I draw sin t curve, how it look like? Sin t curve. Let's check it out where it is going to be positive, where it is going to be a negative value. Zero, pi, 2 pi, minus pi, minus 2 pi, like that. So if I draw u of sin t curve, so let's see, 0, pi, 2 pi, 3 pi, like that, minus pi, minus 2 pi. If you observe carefully, in u of sin t curve, sin t is nothing but the argument. Sin t itself is positive between 0 to pi. Whenever the argument is positive, the function value is 1. Next, pi to 2 pi, the argument is negative. Sin t is nothing but argument. The argument is negative. Then its value going to be 0. 2 pi to 3 pi, again it is positive. Again its value is 1. Again drop to 0. Next, 0 to minus pi, its value is 0 because argument is negative. Again 1. Like that it will go. Again 0. So this is the function what we are going to get, u of sin t, which is nothing but a square wave. Okay, make a note. Argument means inside the bracket value. Whenever the argument is positive, whenever the argument is negative. Positive means 1, negative means 0. Here one very important point we have to see. Unit step function is represented with u of t. What is the coefficient here? 1. I told you coefficient of a function is also called as a strength. What is the strength in this case? 1. What is that 1 indicates? So u of t curve looks like this. There is nothing but amplitude of the curve. If I write 2 u of t, that means its amplitude is going to be 2. That is as simple as that. So here, suppose if k u of t, if I write, that k coefficient is equal to strength, which is k is nothing but amplitude of the curve. Amplitude. Okay. So why I am insisting these values is, suppose in an impulse function the coefficient indicates area, whereas in the step function it indicates amplitude. Okay, be careful. So many people confusing with a step function and DC signal. So try to see what is DC signal. Suppose if you take x of t is equal to some let's say k for all the values of time. That means for every instant of time its value is equal to k. How it look like? Its value is equal to k for all the values of time. That's what the DC signal means. Means there is no discontinuity point. Its value is always a k. Suppose at 0 its value is equal to k. At -1, -2, -1.5 everywhere its value is equal to k. So that is the difference between DC signal and step signal, because step signal having a discontinuity at 0 and only for positive values of time it exists, whereas DC signal does not have any discontinuity and it existing from -infinity to +infinity. So t value is ranging from -infinity to +infinity. Still its value is k only. Okay. Take it. DC signal. Next signal, unit ramp function. Unit ramp function. It is denoted with a r of t. It is denoted with r of t. Mathematically, it can be defined like this. R of t is equal to maybe t, maybe 0. Its value is t when t greater than 0. Its value is 0 for t less than 0. That's what the mathematical definition. At t is equal to 0 also its value is 0. No need to worry. We don't have any discontinuity here. How it look like? Up to 0 its value is 0. That's what the meaning is. Up to 0 its value is 0. After 0 its value is t. It is something like this. R of t is y-axis. T is x-axis. That is y is equal to x. Y is equal to x means it is a straight line passing through origin, but only for positive values of time. What is y is equal to x line? Actually it is straight line passing through origin. It is existing for negative values of time, positive values of time. But in the ramp function it is existing only for positive values of time. So this is how it look like. What is the slope of this line? Which is 1. What I mean by slope is 1. 1 unit change in x-axis leads to 1 unit change in y-axis. Suppose if I go with 2, then its amplitude is 2. That's what the meaning of slope is equal to 1. Slope is equal to 1. Okay. That's what the ramp function means. Make a note. Straight line passing through origin, but existing only for positive values of time. Suppose if I write y is equal to x curve, that means simply x of t curve, which is nothing but t. Suppose if I take a curve which is t, x of t is equal to t. That means a curve value itself is equal to t. That means we don't have any boundary. So it is existing from positive values and negative values of time, whose slope is equal to 1. If this function is multiplied with u of t, if this function is multiplied with u of t, I told you any two signals are multiplied, that means we have to multiply the amplitudes at each and every point. So if I multiply before 0 its value is 0, so 0 multiplied with anything is 0. After this its value is 1. If I multiply the any signal with 1, I can get the same thing. So the result is nothing but it is a straight line passing through origin, but only existing for positive values of time. slope is equal to 1. Is it nothing but r of t? Yes. So can I simply conclude that r of t is nothing but multiplication of a function which is t and u of t? T u of t. So t, simply if I say t, that is existing for both positive values of time and negative values of time. Whenever a function is multiplied with u of t, which indicates the existence is only for positive values of time. So keep that in mind. Whenever a function is multiplied with u of t, that indicates it is existing only for positive values of time. Okay, make a note. How to understand one thing. Strength again. If I write t u of t, or we can write r of t. R of t means t for t greater than 0. What is the coefficient here? Coefficient, which is a strength, which is 1, which indicates slope. Which indicates slope. If I write k r of t, the coefficient, which is equal to strength, indicates slope. So remember this thing, very important. The coefficient in a ramp function or strength of the ramp function in the form of slope. So I am telling you again. For an impulse function, strength is in the form of area. Step function, strength is in the form of amplitude. And for a ramp function, strength is in the form of slope. So this is very important to remember. Okay, make a note. Suppose if I write draw 2r of t, how we can draw this? 2r of t, which is nothing but 2t or 0. 2t for t greater than 0, 0 for t less than 0. So if I draw this curve, y is equal to 2x curve. So y is equal to 2x curve, how we can draw this? It is a straight line passing through origin with the slope is equal to 2. Slope is equal to 2. What do you mean by slope is equal to 2? That means for a 1 unit change in x-axis, there is a 2 unit change in y-axis. So slope is nothing but change in y-axis by change in x-axis. So if I take at 1, what is the amplitude? 2. That's what the slope is equal to 2 line means. Okay, take it. Next, unit parabolic function. Unit parabolic function, which is usually represented with a p of t, parabolic function, whose value can be t square by 2 or 0. T square by 2 for t greater than 0, 0 for t less than 0. Graphically, we can show this like this. It is a parabolic function. This is p of t. Its value is 0 for t less than 0. Actually, t square by 2 means it is having a part in the negative part also. It is having a portion in the negative time axis also. But I said for t greater than 0 only, so we are considering only positive part. Can I write this function p of t in short like this? T square by 2 into u of t. So any function is multiplied with u of t. What is that indicates? the signal is existing only for positive values of time. That's what the meaning of it. So for t greater than 0 only it is existing. Take a note. Okay. Listen, this is a very interesting point to remember. If I write a function which is like this, integral minus infinity to t delta tau d tau. So let's say if I write minus infinity to infinity, so if I take simply minus infinity to plus infinity delta tau d tau, its value is equal to 1. Everybody knows it. There is nothing special about it. But whenever if you take minus infinity to t instead of infinity, then this integral is called as running integral. So remember, if I take minus infinity to t, this is nothing but running integral. It is not going to give you a constant value, it is going to give you a time varying value. Whereas if you take a particular limits, suppose let's say minus infinity to infinity, you are going to get a constant value, that is area under the curve. But it is not a area simply, it is going to be running integral or time varying area. So let's see, check it out. Delta tau d tau. Delta tau is existing at tau is equal to 0. Suppose if I take t value is equal to -2, t value is equal to -2. Because the function is existing at tau is equal to 0, if I take the limits only from minus infinity to -2, then its value is equal to 0. Understood? So its value is equal to 0 when t less than 0 and its value is 1 for t greater than 0. I hope you understood what I am trying to say. Suppose if I take t is equal to plus 2, minus infinity to 2, the impulse function is existing, so that we can say its value is equal to 1. So this is nothing but the definition of u of t. So whenever you take a running integral of impulse function, then you are going to get u of t. Suppose if you take a constant area, that is minus infinity to infinity, its value is equal to 1, no doubt. But what is the difference between them, you have to understand. So from this, if I do the differentiation, du of t by dt, we are going to get impulse function. This is what the relation between u of t and delta t. Again the same thing, running integral u of tau d tau. Its value is equal to again 0 maybe t. So its value is 0 maybe t for t greater than 0, sorry, t less than 0, t greater than 0, which is nothing but r of t. If I do the differentiation of r of t, which is u of t, in the similar manner, running integral of r of tau d tau, which is p of t, differentiation of p of t, differentiation of integration, running integration, is going to give you same curve r of t. These are the relations between delta t, u of t and r of t. Okay, so it is actually what we can say sequence: delta t integration u of t, integration r of t, integration p of t. In the differentiation, suppose p of t differentiation r of t, r of t having differentiation, which is going to give you u of t. Again, if I do the differentiation, it is going to give you delta t. I hope you understood. So this is the sequence you have to remember: delta t, u of t, r of t, p of t. That is the integration sequence. Differentiation sequence: p of t, r of t, u of t, delta t. Okay, make a note.